This video is the last in the series about project management. In this one, we're going to talk a little bit about uncertainty in project management. I'll refer you back to the short PowerPoint video that I gave to introduce this concept. But this one, I'm going to work through a specific example. And the question becomes, what if there is variability? We can then come up with an expected time. We can then also look at the probability of meeting specific milestones. And this video here is to work through an example question. So let's proceed. So here we have the type of question we might get. Usually we reflect uncertainty with three numbers: an optimistic completion date, a most likely completion date, and a pessimistic completion date. And that is pretty much the most common way we build uncertainty. It's not the only one, but it's the sort of simplest one that most introductory operations management courses introduce. So we have 5 activities here. We have optimistic time for each activity, the most likely time for each activity, and a pessimistic time. And in addition, we get the precedence relationships, which we always need in order to complete the project network. So the questions could be: draw the network. What is the expected completion time? What's the variance of the critical path? If you're supposed to finish the project in 21 days or there's a penalty, what is the probability of finishing on time? And what is the probability of taking too long? There's a bonus to be paid if you're done in 17 days. What is the probability of getting a bonus? What is the probability of completing between 17 and 21 days? And what is the date that yields a 95% chance of completion? So that gives us the basic question, and so we can go through now and complete the question. The first thing we need to do is calculate expected times for activities. And to do that, for this sort of approach with optimistic, most likely, and pessimistic, we get expected time for a task is equal to A, which is optimistic, plus 4M, most likely, plus B, which is pessimistic, over 6. So essentially what that's giving us is a weighted average with more weight going on the most likely outcome. So for each of these, TEA, we had 5 plus 4 times 8 plus 11 divided by 6 is equal to 8. The expected time for B is equal to 4 plus 4 times 8 plus 11 is equal to 7.83. And we would continue to work that way through the, so TEC is equal to 6. I'm not going to calculate each one of these. The 2 examples should suffice. So that gives us the expected time for each of those activities. Now we have variability, so the next thing we need to do calculate the variance of activities. And the variance is sigma squared for specific task is equal to B minus A over 6 squared. So this variance of task A is equal to 11 minus 5 divided by 6 squared is equal to 1. The variance of B is equal to 11 minus 4 divided by 6 squared is equal to 1.36. And we would do the same thing for the others. For C, it's 0.11. For D, it's equal to 0.44. And for E, it's equal to 1. So, calculating the expected value and the variances is a relatively straightforward process. So, the next step will be to draw the project network. Let's make sure I'm still lined up nicely here. So now we're going to draw the network. Start with a start node. A has no predecessors. People are often tempted to put the most likely in here. They skip that calculation step. We are going to put in the expected value. So the expected time for A is 8. We then have B, which has no predecessors. Expected time is 7.85. C, which is preceded by A, as we can see here, has an expected time of 6. D, which is preceded by A, has an expected time of 4. And E, which is preceded by both B and D, has an expected time of 7, and that is it. The rest go into the finish node. So we have then the network. We can do our forward pass, 0, 7.86, 0, 8, 8, 14, 8, 12. We have 2 going in here, so we pick the largest one, 12, 19. So the project takes 19 days. The expected time is 19 days. We can then go backwards, 19, 12, 12, 4.17, 12, 8, 19, 13, 8, 0. So expected completion time is 19 days. Critical path is equal to ADE. This has slack in it. This has slack in it. The only path that is critical is ADE. Remember, the mistake people make is putting in the most likely here. You don't put in the most likely, you put in the expected value. The variance of the project is equal to the variance of the tasks on critical path is equal to 1 plus 0.44 plus 1 is equal to 2.44. 2.44. So the variance of the project is 2.44. The expected completion time is 19. So let's start working through the questions that we got then. The first question is, what is the probability of finishing in 21 days or less? So to do that, we need to calculate a Z value, and the Z value is equal to target time minus expected time over the standard deviation of the project. So TS is target time. So, and the standard deviation of the project is the square root of the variance of the project is equal to the square root of 2.44, which is equal to 1.56. So in this case, Z is equal to 21, which is our target time, minus 19, which is the expected time that we got when we drew the network, divided by 1.56 is equal to 1.28. So that gives us a Z value. Then we go to the standard normal table, and we look up that Z value. So this is a standard normal table that I had handy. There's usually one in any operations management textbook, or if you Google standard normal table, you will find one. And it is essentially the area under the curve for values of Z. This particular one is for ranges that are above the mean, which is what we've got here, TS minus T, 21 minus 19. And we would go look up 1.28, 1.28, and we would get 0.8997. So we can round. The probability is 90% that we will finish in 21 days or fewer. We know that because it's this, the probability reflects all of the outcomes up to 21 days. And really what we're interested in is that we're done in 21 days to avoid the penalty. So then it asks us, what is the probability of taking too long? Which is probability of taking more than 21 days is 1 minus 90% equals 0.1 equals 10%. We know that all of the possible outcomes have to sum to 1. So if 21 days or fewer is 90%, then more than 21 days has to be 1 minus 90% is equal to 10%. So that's how we got that number. So let's take a look at the next question we have. Bonus if you finish in 17 days or less. What is probability of bonus? So here we have Z is equal to 17 minus 19 divided by 1.56 is equal to negative 1.28. Now you can go to a different table, but we're going to use the same one because the normal distribution is symmetric, right? And we looked up 1.28 and we got 0.8997. So we know that if we have positive 1.28, we are here. Then if we have negative 1.28, we'd be exactly the same amount on the other side. And so we can just take, for 1.28 positive, we know that this area is 90 and this area is 10. When we just flip it to the other side, we then know this area is 10 and this area is 90. So we can get that the probability of finishing within 17 days to get the bonus is 10%. So we have a 10% chance of getting the bonus. What is the probability of finishing between 21 and 17 days? So if we look at remember we looked at, and I apologize for my normal distributions, 21 was this area, right? Anything less than 21 was 90%. We also know that 17 was that area up to 17 because the middle here is 19. And so we know that the probability of finishing in 21 days or less includes the probability of finishing in 17 days or less. So we can then take the probability of 21 minus the probability of 17 equals 90% minus 10% equals 80%. So that what we've essentially done is taken this amount out of here and just figured out how much is left there, and that's 80%. So we have an 80% chance of finishing between 17 and 21 days. Relatively straightforward, just needs us to think a little bit about the symmetric normal distribution. The last question we got here was how many days to get to a 95% probability. So in this case, all we're doing is testing your knowledge of the formula. So what we want to do is figure out what is Z at 95%. So we would go back to the standard normal table and we would look at 0.95. So we've got 0.9495 and 0.9505. So we could pick one or the other, or I am going to pick the spot exactly in between them, which isn't going to be exactly right because it's not linear, but it's going to be even closer than one or the other. So Z is equal to 1.645 from the table. So then we can just use the formula for Z. Our target days is equal to, minus our expected days, which is 19, over our standard deviation, which is 1.56, which we had from before, is equal to 1.645. TS, now we're just going to do algebra. TS minus 19 is equal to 2.57. TS is equal to 21.55. So 21 and a half days or less gives 95% probability. So, incorporating variability in, calculate expected completion times, calculate variances, draw network, and determine critical paths. Expected completion time, and variance of project. And then use Z in the standard normal table to calculate probabilities. So, relatively straightforward. I would say this most students don't struggle with. The only mistakes they make are generally by putting the most likely time into the project network rather than the expected time. Otherwise, it's a relatively straightforward process and easier than crashing, I would say, in my experience with previous students. So, practice it a little bit, give it a try, and if you have questions, let me know. Good luck.